Let's move on with the loop discussion. As we discussed earlier on, loops are very important structure that allow us to go back to some part of the earlier sequence of instructions, that is our Python program. So if we want to repeat a part of our Python program certain number of times, then the way we implement this logic in Python will be to have a loop, right? So loop always means go back to some parts of the previous earlier executed statement. So in Python, there are two ways to implement loops. One is by using the keyword while. The other one is by using the keyword for. And the main distinction between the two is whether we, at programming time, uh, know in advance whether the number of times to loop over is finite and definite. That means we know already we like to go through this sequence segment 10 times. So the 10 is already known when we are programming, so we would choose 4. All right, so definite and fixed and known in advance, so then we use 4. Any other cases, like not sure, maybe 10, I don't know, could be 20. Actually, I want to repeat infinite number of times. In all these other cases, when the number of times to loop over is not known in advance during programming, then it tends to be better to use while. All right. So why do I use this rather indefinite description of it tends to be better? Reason is because ultimately the logic that is expressed by while can also, with a bit of additional code and awkwardness, implemented by for loop and vice versa. If you have a for loop, I can also write with a bit of decorations uh, a while loop to do what your for loop does. The only sort of additional benefits we get in properly choosing while or for is the clarity of the code, the simplicity of the lines, and of course, then when your code is clear and it's simple, both in terms of the number of characters and ability for us to understand, then your logic is highly reusable and self-documenting. So it's really, really useful in that sense. So choose the choice of your loop wisely based on, I may suggest, whether we know the number of times to loop over in advance and it is fixed. All right. So if that's the case, then do for. Any other cases, we use while. So the while in its simplest form takes starts with while, just like if starts with if. All right, so we just copy the loop over. And there's a red mark here saying that we wanted the while expects a body block. So whatever is in the indented and shown as a body statement, all those will be repeatedly run so long as this condition here evaluates to a true. So long as it evaluates to a true. So we can ask Python, um, Python, is 1 greater than equal to 2? And Python says no, false. So what that means is that uh, the first time Python runs this statement, is this true or not? And since it's false, the entire body block is not executed. It's not run. So Python skips over to the next sequence, which is the print function. So it will print out finished while loop. Right, so let's just run it. And you see that there's no single instance of oh no being printed at all because it starts off being false. All right. Now, of course, this is not very interesting, but just to illustrate the fact that so long as condition is true, body is executed. But the first time, even for the condition to be false, the body statement is not executed. Now, that is not a very interesting loop. Let's do another loop. Now, all loops have basically 3 main segments to it. One is you have to initialize the variable. And you choose a variable. So that's the first thing. You choose a variable. It has to be a loop variable. A loop variable is just like any other variable name, right? But we use it to step through the loop. Why do we have a loop? Because we want to repeat the sequence of instructions. But if you repeat the sequence of instructions, that's just copy and pasting, right? It would be best if we can also additionally repeat the instructions over different data. And that's where your loop variable comes in. Your loop variable changes the nature of the data, even though the new set of data follows the same set of logic as implemented by your loop statements. So here, our loop statement is very simple. It prints out the value of I, and this just tells print not to print the extra new line return so that our numbers go horizontal. That's all. So I said there are three components you need to manage. One is have a loop variable. Second is you must initialize the loop variable. So we set it to 0. That's important because if you don't do that, I will not be defined. The variable I will not be defined. And the third part is to update the loop variable, usually, almost always, at the end of the loop. All right. Sometimes this update can occur at several parts of an if statement, but you almost always have this need to update the loop variable. That means change it to another number, change it to another value in general. So three things: choose loop variable, initialize the loop variable, and update the loop variable, usually at the end of the body statement. So what does this do? Let's just do a quick run through. First, we set I to 0. Then, is 0 less than 10? Yes. So we print a 0, right? Leave an additional space. Then we change 0 plus 1 and set it to I. So now I becomes 1. Go back, because loop at the end of the body statement automatically always goes back to the beginning of the loop. Wherever the loop begins. So that is here, and we check. So condition is always checked after every single execution of the body statement. I now is 1. Is it less than 10? Yes, it will print out a 1. Then I becomes 2. Is 2 less than 10? Yes, it will print out a 2 and becomes 3, and so on, until I becomes 10. All right, so I is 10. Is 10 less than 10? Is 10 less than 10? Of course not. So it will terminate immediately without printing the 10. So if we run it, we'll see that as expected, we get 0 space, because the 0 and the space, they are supposed to be printed out according exactly to our instruction. It will print out everything, including the 9 and the space. All right, this ending space is visible like with X-ray vision if we select the line here. Okay, so this is a very basic and template kind of while loop statement. Suppose now I want to print 1 to 10. All right, one easy way to do it is to just keep the variable and the loop data constant. So it's ranging from 0, 1, 2, 3 until 9, but I derive the printing data by adding 1. So 0 becomes 1, 1 becomes 2, and so on. So if we run this, we do get the answer. But let's be a bit more flexible, more versatile. So suppose this print is written by our fellow teammate in another programmer, our fellow teammate, and we are not supposed to alter the data. It has to be pure I, just sending it in. So then we have to change the loop variable. So we would then initialize I to 1, because we start printing I as 1 first, then 2, then 3, right? And we want to include the value 10. So we say while I is less than or equal to 10. Alternatively, since I is integer, we can say it while I is less than 11. Right, but I think I will choose less than or equal to 10 because the 10 is clear and the equal sign says I want to have that. So if we run it like this, then we'll see that the 1 to 10 is again printed out. And of course, some of you might have read this before. Another way to say I equals to I plus 1, because the I and the I, they are repeated. Python allows you to say plus equal to I. So we can say this is same as saying I equals to I plus 1. So let's run again. and we see that we are again getting the same results. Okay, so this is great because we have explicit control over every single part of the loop. So the loop variable, the initialized value, the condition of course, and then the update. We can also have multiple areas to update. For example, we can update differently depending on whether I is even or odd. So we can say if I is even, because the remainder of I after dividing by 2, that's the percentage sign. If the remainder of I after dividing by 2 is 0, then we have even I, right? I is even 0 to 0, no. So 2, 3, 2, 4, 6, 8. So then we print I, right? No, we print I all the time, right? If I is even, then we want to update I by 2. So otherwise, we update I by 1. Okay. So if I is even, we update by 2, it becomes even. All right. Well, it will never be odd. We can do this. So next time I is odd, because any number, any integer is either odd or even. So if this is even, then in this case, we have odd I, right? So in the else case, check if I is even, then we add 3. So example, if I is 1, if I is 2, so that's even. So 2 plus 3, I becomes 5. Then we go back, we print 5. Okay. Now check 5. 5 divided by 2, remainder is 1. 1 is not 0. So we'll do here. So 5 plus 1 becomes 6. I becomes 6. Yeah. So we can do this and see what's the outcome. And at first I is 1. So I is odd. So I plus 1. So I becomes 2. So we print 1, then we print 2. 2 is even, right? So now we plus 3. And 2 plus 3 is 5. So the next time we go back, 5 is less than 10. So we print 5. 5 is odd, right? So we will do here, becomes 6. We will print 6 because 6 is less than 10. Right? Then we add, because 6 is even, this time we add 3, it becomes 9. So is 9 less than or equal to 10? Yes. So we print 9. And because now I is odd, because it's 9, so plus 1, we get 10. Is 10 less than or equal to 10? That's true. Is 10 less than or equal to 10? It is true, right? So we do go in one more time, print 10, but this time round, when 10 is divided by 2, the remainder is 0. And so we add 3, it becomes 13. Finally, we do one more check. Is 13 less than or equal to 10? No. So exit. So this is why we get 1, 2, 5, 6, 9, 10. Right? There's a strict logic to it that is not random, it's very strictly followed. And because of that, we control every aspect of Python's behavior. Moving on, let's look at the other keyword that we can use to implement loop. So that's the keyword for. So as we discussed earlier on, whenever we have a very clear idea, a fixed number, right, it won't change, of loop number of times to execute, it is best, not to say that it's impossible, but it is best to use for loop. Let's just try it out and see. All right, so here, for offers us another way to run the loop. So the structure is for loop variable in a list of values. Do the following loop statement. All right, so what we do is this.